Looking down into the crusher, the outer circle represents the stationary bowl covered by the concaves, and the inner circle represents the main shaft covered by the mantle. The main shaft rests in the eccentric bushing at the base of the crusher, and as the eccentric rotates, the base of the main shaft moves in a circular path around the crusher center line. Viewed from the side, the motion of the main shaft is like that of a pendulum. As the gap closes, the ore is nipped and broken. When the gap between the mantle and the concaves increases, the broken ore is released and falls lower in the crusher cavity where the gap is narrower. Ore that is fine enough falls through the crusher, where it is usually picked up by a feeder or conveyor belt. Ore fed at the top of the crusher fills the vacant space. We will observe the action on an idealized spherical particle which enters the crusher from above. The particle falls into the crushing chamber until its size prevents it from falling any further. It comes to rest at level 1. As the mantle moves to the open side, the gap between mantle and concave at level 1 opens and the particle drops to level 2. Since the particle has not changed size, the open side gap at level 2 must be equal to the closed side gap at level 1. As the mantle moves back to the closed side, the particle is compressed from its original size to the closed side gap at level 2. The amount of reduction is equal to the throw at level 2. The sequence is repeated. First, the mantle opens, allowing the particle to drop further into the chamber. The open side gap at the new lower level is equal to the closed side gap at the previous upper level. Next, the mantle closes, again compressing the particle. The process continues. The particle falls into the open side gap. As the mantle returns to the closed side, the particle is compressed and broken. Notice with each cycle the particle drops further, and the compression is greater than the previous cycle. This is because of the increased throw of the mantle as the particle moves downward. Finally, the particle is small enough to escape the crusher. In this demonstration, it is smaller than the open side setting, but one as large as the open side setting could pass through if it arrived at the exit point just as the mantle was moving to the open side position. To summarize, the throw of the mantle gets larger as the particle moves down in the chamber. The amount of reduction at each level is equal to the throw at that level. Because the throw increases going downward, so does the amount of reduction. Since the reduction is increasing, the particle drops a greater and greater distance into the chamber with each stroke.